William, the last time we spoke, you told me that you're going to answer this question for me. Where do 3D designs come from?
So 3D designs, first of all, they come from everywhere. But for you as a consumer, there's a difference between consumer designing and industrial designing and, whatnot. For us as consumers, there's plenty of places where you can get free designs. The first place I look for designs are these websites
Mhm.
that have existed for a few years now. Here we go. And first up is this one called Printables. And Printables has a bunch of stuff. Now, this stuff is all free, meaning if you see a design, you can download it. You run it through a thing called a slicer, which I'll show you, and then you can print it. Okay. So you can come here, and the most common thing you're going to do is, you can just browse. Here's some featured designs, featured designers. I can go and explore models. And there's just all sorts of things in here. Like, here's a design for a 3D printable little action figure, and you piece
Ah,
that thing together. It comes on, here's all the pieces,
oh, and
and
then
you
you
print it.
assemble it. Yeah.
Yeah, you print it like that, and then you assemble it. And then you'll oftentimes see where people have done this, and they give comments, so here's someone printed in different colors and they're posing them. It's all fun. I printed this one with my son and daughter just so they could play with them, right? And they'll give you hints like, oh, I printed using this material or that material or these particular settings on this printer. So there's that kind of thing. Oftentimes I'll look for, I might actually have something that I'm looking for. Like I have these electric drills and electric hand tools,
Hmm.
and the brand is Milwaukee, and I'm looking for something to attach to my battery. So I can just type in some search terms like, oh, here's some various 3D printable things related to Milwaukee batteries. Here's something that'll allow you to stick it on the wall and hang your batteries off the wall, right? You can just slide them in there. Or here's an attachment. I saw one in here which is converge. Here's one that converts the electrical connector into this other connector, this yellow thing,
Hmm.
which can be used for hooking up like various hobby devices and whatnot. So people come up with all sorts of. So the first place to start is some website that has just free stuff, because a lot
Okay.
of times as a consumer, where you're just printing one-offs for yourself at home, you can just go to this place and find them. So that's printables.com.
Printable.
Yeah. Another one is Thingiverse. This is a place where I myself have 150 designs that I did way back in 2011. But it's the same idea, right? You've got all sorts of things here. Here's a little thing that holds those coin cell batteries. It's a battery holder. It's like, oh, I need that. Here's a key to turn on some sort of thing that might be your house. Like my fireplace needs a key like this to turn on the gas. You'll find lots of figurine sort of stuff because that's common. You'll find mechanical things like this. Things hold SD cards. This one's kind of cool. I've actually printed this one before, where it's an active lift. So it goes up and down, you know, and it prints all
That
in
is
one print. You don't have to assemble this one.
wow.
It prints in place. You kind of turn the crank and it cracks it a couple of places, and then it just works. It looks like that. This one, they replaced the screw with a steel screw, but you can just print it in place. So if you needed a lift for something, whatever, you can do that. Let's see if I can find my name in here. So back in 2011, I was doing a lot of designs in this space. So here's the one that got me into 3D printing in the first place. This is the connectors for
Oh, for the
straws.
straws. Yeah.
Yes. So this is the design that started them all for me, these flange connectors. But I have all sorts of designs that I've done, like the peanut. you know, these were explorations in trying to, just keep in mind, this was 2011, so a long time ago, where design tools weren't that great for consumers. But I was able to do a whole bunch of stuff related to curved surfaces and geometric shapes and all sorts of things like that. So Thingiverse was one of the first places for consumers to get free designs. And again, these things, you go and you click on here and You say, get the files, and
Right.
you download it. So here's the files related to that thing. You just download it and you get the files and you can print them out. And I'll show you the process of that. So Thingiverse is one of the oldest ones. They still
Mm-hmm.
exist. I think it's a company called oh yeah, there we go. Ultimaker, I think, bought this from the originators of it. Ultimaker is a company that makes 3D printers.
Okay.
And then another one is Thangs, THANGS.com.
Thanks.
And again, you can search for stuff here.
Mm-hmm.
I think in this place, you can actually create a store where you can have followers and they can give you contributions and all that sort of stuff. So the model is slightly different.
Okay.
But there's also a bunch of free designs, so you can still go and find things that are in here that are free, or you can follow a designer. You can create a member. You can join a
Membership.
membership.
Yeah.
So then you're paying them. It's like a Patreon sort of thing, where it's like, oh, I'll pay you $10 a month, and I get access to your designs. So that's a way of you supporting designers pretty easily. So to answer the question, that's where designs come from. Now let me show you an example of stuff that I've printed. A lot of stuff that I've printed that comes
Mm-hmm.
from that place. So there's this one thing going on right now called Gridfinity,
Mm-hmm.
and it's an organization tool. Let's see if I can go over here to printables. And it's started by a particular designer, Zach Friedman, who said, "Oh, I want to." It actually started from another place, but he kind of modified the design and came up with a new design. But it's a way to organize stuff. So
Mm-hmm.
when you have just stuff on your desk or tools in your
Organizer
toolbox, or
tools. Right.
yeah, it's a way. It's a fixed grid of things, and the grids look something like this. This is called a
Uh-huh.
base plate.
Uh-huh.
And then it's like, oh, I need a place to organize all my hex bits. These are things that I use for screwing stuff in. And I've got a few of these and I can say, okay, I put that on the base plate, and then I've got another set of them
Mm-hmm.
and some attachments that go in the drill. And I can add that to my base plate because these might be individually just kind of rolling around my drawers or
Right.
whatever.
Exactly.
It's like, where is that thing? It's like, oh, just look for the orange
Oh, right.
thingy, and that's where all your bits are, right? Or I printed another one I need for my desk here in the
Mm-hmm.
office. I mean, everybody has like stick-it notes, right? So
Right.
here's just one of those sticky note containers.
Well,
So I printed this, and the bottom has the grid pattern.
oh, so you could add that onto your
Yeah, so I've
yeah.
got my grid, and I have
He's
one of these in the office, so I put that on the grid like that. And
mm-hmm.
having the grid just keeps things together,
Organize
right?
right. Mm-hmm.
Yeah. And then it's like, oh, I need something to hold my pencils and pens, so I printed this one. And similarly, I have batteries, and they were in a drawer over here in just a regular, plastic drawer. It's like, oh, I need to organize that because otherwise my batteries are just, where's those CR 2032 batteries? Well,
Right.
they're in a little thing like this, nicely organized, and they're fitting into a slot. So now I know exactly where the batteries are. It's color coded, and they're nicely organized, so I can just pull out those batteries and get it. So this is a whole organizer thing. And of course, this is still sticking to the question, where do 3D designs come from? They come from you needing something. On the creator front, I'll show you the tool that I used when I first got started doing 3D design. So I use this. There's many tools in this space. Okay,
Mm-hmm.
the more professional. I'll start with the low end, not the professional tools. So there's professional tools that cost thousands of dollars and require tens or hundreds of or thousands of hours of time to learn to use them properly. And you're an industrial designer and all that. I'm not an industrial designer. I'm not going to spend thousands of hours on those tools. I'm a programmer, right? So when you think of design, you have to break things down into component parts, right? And I'll show you that in this program. There's a particular methodology called constructive solid geometry, which is CSG. Big words. What does that mean? It means
Yes.
you take things like a block, a cylinder, a triangle, and a
Uh-huh.
sphere, and you kind of take chunks off, add chunks to, and that's how you construct a design. So when you look at something like this,
Uh-huh.
which is a pencil holder,
Pencil holder.
yeah, so it can take all sorts of pencils in here. When you really look at it, it's like, well, what is this? They're just
Hmm.
a bunch of cylinders, right? Well,
Right.
a cylinder is just a round tube
Right.
with another round tube that's smaller, kind of taken out of it. And then this whole construction is just a bunch of round tubes that are hollowed out, stuck really close together, right? And then they're sitting on top of a rectangle that has rounded corners, right? So when you think of it like that, it's like, oh, I need round tubes, I need a rectangle, I need the tubes to be hollow.
Right.
So when you look at a tool like OpenSCAD, this particular design tool allows you to do constructive solid geometry using code, which is really important to me because I like looking at, I can do code. I can't do the 10,000 hours of UI work required to use those visual designer tools. A lot of people are visual designers, so they want visual designing tools that you can click and drag and all that
Yep.
stuff.
Yep.
For me, it's like, I'd rather write code, you know? So in this case, I won't go into what this code really means, but I'm writing code. So I say I've got a cube and I've got a sphere. The cube is at the center
Okay.
and I'm going to combine that cube with the sphere. So union means combine, okay?
Mm-hmm.
So on the left here, you see a cube and a sphere
Mm-hmm.
combined, right?
Combine. Yep.
Union. In this one, I'm doing the intersection. So which parts of both of these objects, right? Which parts are in both of the objects? So the intersection of those two objects is this middle one, right? So it's only the parts that's the sphere and the cube.
And the cube together.
And that's
Okay.
why you end up with this thing that's neither sphere nor cube because it's
Yes.
kind of cut off. It's only the parts
Right.
that are in both of them. And then
Okay.
this last one is the difference. You
Mm-hmm.
take the cube and you subtract the sphere,
Sphere.
right? So that's how you do design like this. And then this turns into all sorts of things. This one that I'm showing here can be completely done in code like that
Uh-huh.
with just more complex things. So take the cylinders and union that with a rectangle, and then you end up with something that looks like this pencil holder. All right. So this is called constructive solid geometry. This particular tool is called OpenSCAD, and it does exactly that. A lot of people will look at that and go, "No, thank you. That's too complex for me." It's like, yeah, but this is important, and this will come back later when we start talking about AI trying to do it for us. Besides that, the tools still sticking in the consumer grade of things. I'll show you another one called FreeCAD, which has been around.
Is
So FreeCAD, let's see if they have some. Yeah. So here I'll share with you FreeCAD. So FreeCAD it's a free tool. You can pay $5 a month or something like that. Pretty cheap. It's online and downloadable, but it'll allow you to create things. These pictures that you're seeing here are actual designs done in FreeCAD,
mm-hmm.
and it's more complex. It's got more menus to it, but you click and drag your mouse and drag out a cylinder, a square, and pull dimensions. This is more of a traditional CAD software that a typical designer would be using. Very, very simple, very basic, but it really gets the job done. All the stuff that you would see on, or most of the stuff you would see on printables or Thingiverse or wherever, can be done in this kind of a tool. So you learn OpenSCAD. Now, I had created
Okay.
a tool called Banate CAD a long time
Hmm.
ago. And the language I used there was Lua
Hmm.
because it was really simple. So I created a 3D programming environment that was like OpenSCAD, but using Lua instead. Because I liked that language better, it was much faster than the OpenSCAD stuff and had all the same features that I wanted. There are people who've done that in Python, but mostly OpenSCAD is the dominant one where you're writing code. I want to say it's the only one at this point that's really where you write code. All the other ones are more visual, like this FreeCAD, where you're dragging and pulling and typing in a few dimensions and stuff like that. So that's FreeCAD. There's another one called OpenCAD, and there's TinkerCAD. So there's several tools in the free category where it's either designed in the web browser. The web browser is the program and the interface is all on the web. Or perhaps you download something and it's pretty simple and it's on your machine. But those are all kind of free or relatively inexpensive tools.
Okay.
At the very high end are professional tools like SolidWorks has been around forever, well known for people who are professional industrial designers and stuff
Designers.
like that. You can turn SolidWorks models into things that are 3D printable. And if you're a design shop that's actually doing industrial design, you might do that. There's plenty of people who are industrial designers who in their free time are doing 3D stuff and they continue to use SolidWorks because that's what they know.
That's what.
They spent
Yeah.
the time
Hmm.
learning it. That's what they know. That's what they use. I personally will never learn SolidWorks because it's expensive, first of all, or AutoCAD. It's expensive and I have no need for that, right?
Yeah.
I mean, I'm
Hmm.
not going to design a car.
Right.
so if I'm going to design some stuff for my desktop, yeah, I don't need those kind of tools. Yeah, let me share just one more set of tools from one particular company.
Hmm.
So Autodesk has been in the design world forever. I mean, I can remember Autodesk from when I was in college. So back in the Stone Age, and they do industrial design, architectural design, mechanical design. They are at the root of running industrial machinery and all the rest. They have two offerings that are relevant to the consumer. The first one is called Tinkercad,
Hmm.
and you can kind of look at by the toy thing that they have that they're demonstrating there. It's like, yeah, it's for that meant for students, elementary school kids, and even the name Tinker,
Yes.
Tinkercad. They're appealing to getting you in at an entry level. It's really simple. You can get started with a student account, a personal account, whatever. Just jump right in. So a lot of people do stuff in Tinkercad
Okay.
because it's like, oh, it's so simple, it's
Yeah.
meant for me. And it's limited in what it'll do, but it's good enough for a lot of stuff, right? The
This is
same
probably where I
company,
would start.
yeah, you would probably start with Tinkercad,
This
right?
is me.
Because like, I just want, it's like, let me throw a couple of blocks together and some,
Yeah. Let's make
some
a bear plane.
cylinders and look
Yeah.
what I did, Yeah, kids take to this and they will start generating stuff, and now they're in the Autodesk pipeline, right?
Yeah.
The next one up from that is called Fusion 360, um, which is for adults. And you can see the picture changes. First of all, you can pay a lot of money for it,
Yeah.
You can pay for a yearly subscription, but they have a free trial,
Hmm.
and that free trial will stay free as long as you're not using it commercially. So a lot of people learn Fusion 360 because it's got a ton of oomph. I mean, it's professional grade. I mean,
Hmm.
you can see by the pricing what people use it
What is
professionally.
it? Yeah.
And this is still cheap. I mean, if you're using AutoCAD, the real thing, you're going to pay thousands of dollars per year. But they have a free trial, and the free trial is just as capable as the paid stuff. It's just you don't use it commercially. But the kinds of designs that you do with it are things like this, right? I mean, and they have the ability to run code that's going to manipulate a machine, right,
Okay.
directly. So I'm going to run a milling machine or a lathe or
Wow.
whatever, not just
Yeah.
for 3D printing. This is like the real deal, right?
Yeah. Yep.
So you can create a 3D printable model from it and go print yourself a prototype, which is common. So you print a
Hmm.
prototype and you say, okay, that sounds good. Now let me send the instructions to the lathe or the milling machine and get a real part done, right? So that's where this tool comes in. Tinkercad, you're not going to use that to create
No.
something that you would send to a machine,
Some machine. No.
right? But this one
Yeah.
you are. And it's got all sorts of tools in there to help you do stuff. So it can do analysis of your parts and say, oh, this right here, simulation. So in the simulation, it can say, oh, here's your part, and let me run actual physics through it and tell you whether this part's going to fail or not under what load, right?
Mhm.
So Fusion 360 starts to bring in real world physics, mechanics, and all that sort of stuff. So you can actually see, well, what's going to happen with this part? I mean, yeah, it looks good, but will it actually work according to the
Sure.
function I'm trying to create, right?
Mhm.
So we're slowly going up the curve of Tinkercad. I'm just playing around, I'm putting stuff for my desktop and whatnot. But now I'm getting serious. I'm going to create an actual engine and it's got to work and not fly apart, right? So this is, and then after this, or like I said, SolidWorks and AutoCAD are just more of the same. And I don't use those tools at all, right?
Okay.
So
Yes.
just recently, I noticed, because I have a Chat GPT subscription, they have this new capability called Create a GPT.
Hmm.
So I was curious. So I said, well, what does that do? And I started to create my own thing, GPT Builder. So GPT Builder allows you to create your own GPT. So instead of just chatting, you can create a designer. So can you help me create 3D models for printing,
Hmm.
right? And GPT, absolutely, I can
Yes.
guide you through the
You
process.
can.
Blah, blah, blah. What do you have in mind? So it's now asking me to get started. Could you please tell me more about the model you have in mind? So something to hold post-it notes on my desk. And of course, it'll say creating a 3D model for post-it notes. It's thinking and it's coming up with some things, and it wants to know some parameters, what
What's the
size notes you want,
size?
and all
What
that.
you want to need? You're right.
Yeah, so it's going to keep doing this sort of stuff and go on, and then in the end, it's going to ask, "Well, what format do you want it in?" Well, I want an
Hmm.
STL file that I can send to my Prusa printer. And I go, "Oh, okay, here you go, bam!" Right? No code involved, no dragging a mouse, no visuals, no nothing. You just have this
No, don't.
conversation,
That's it.
right?
Yep. You and it
Now,
asks you the right questions, and once you have the right answers,
right.
you
Now,
got it.
this was very specific. I'm asking it how to create a post-it notes, but I can create a more general GPT that is just model helper, right? I
Hmm.
want it to help me create lots of different kinds of models. So I'm going to feed it. It's going to ask me, well, if I try to ask it things about creating engines and running physics and stuff, it's going to ask me more questions.
Of course.
Can you tell me, the parameters of your models and what are the constraints, or what is the nature of the filament you're using to print? And, you know, then it knows all of that as part of its base knowledge. Now I can come back and say, I need a coat hanger that can hold up to 50 pounds, you know, and I'm going to hang it off of, the edge of a door.
Hmm.
And it can go, oh, well, the edge of a door, 50 pounds, the limitations are this, so it needs to be this thick. And, so it's going to go back and forth based on this knowledge that I've given it to come up with some answer, right? So there you go. Chat GPT can be transformed into this thing that's very specific to a specific domain. There's a new feature they have. So all those tools that we looked at before, where your eyes glaze over because, like, I'm not going to spend the 10,000
Can't
hours
want to do
required
that.
to
I
learn
do this.
that.
I can't
But you
write
can
code,
do, but
but
you
I
can
can do
chat.
this. I can do this.
but you know English, so you can just talk to the thing and say, "Look, man, I need a design to
Yeah.
do the following,"
There
and
you
they'll go,
go.
"Okay, here you go." you know. So there you go. That's the
So how
answer.
long before I could actually get AI to basically design what it is I want them to
We
design?
just did this right now.
So I
You
can do
can
it
do it
now.
right now. Right now. If you got a Chat GPT OpenAI subscription, $20 a month, you can do exactly what I'm doing right here, right now. Right? It
Cool.
doesn't require any code, doesn't require a lot of knowledge. You just
Nothing.
got to chat. Now this is going to take some work. I don't want to mislead you. You can't just walk up to your regular Chat GPT and say, "Give me a 3D model
I
for
know.
this
First,
thing." You got to train it.
yes.
It's got to
Yeah.
learn about 3D printing. But
Yeah.
once it's learned, I can now publish my learned model maker helper as an app, if you will, and I can let you say, "Hey, Stephanie, go to this link and ask it your question." I've already trained it up on how to do 3D
How
modeling,
modeling.
so you can just ask simple questions. And it's like, "Oh, I need a phone case for my own iPhone 15." And I go, "Here you go. Well, what kind of design do you like?" "Oh, I like modernistic, whatever." And I go, "Here you go. You like this? Give me 5 options. Here you go. Here's 5 options. And then, "Oh, I like that one. Give me the STL file for it."
Yeah.
So that's where we are today, right?
So let me
So
ask you
this is,
again.
yeah,
Do you think I should get a 3D printer? Now that you showed me that I can do
absolutely, of course. So
it.
we didn't talk too much about the cost of 3D printers, but you can
Right.
get a good, decent, reliable 3D printer today for 250 to 400. You don't need to spend
Okay.
more than $400. 400 would be high end
High
for,
end. Okay.
yeah, for an entry level consumer, just plug it in and it works printer.
Yeah.
400 would be high end. 250 to 350 is plenty good,
Okay.
right?
And I can get started the I could get started today.
Yeah, the first thing you would do once you got your printer, you would set it up. You would
Mm-hmm.
probably go to printables.com, download something and
Or
print it out.
Thingiverse. That's right. Oh,
Right. You,
thanks.
you you
Something.
print out some trinkets like a mouse holder or whatever,
Yeah.
and you go, "Oh, I'm into 3D printing now." And then you start looking around for, okay, I've now printed 50 trinkets of junk. What do I really need? Right? And then you might see something like, "Oh, this little bracket in my fridge broke. I need one of those."
Right.
And you'll go to ChatGPT and say, "I need this little bracket for my fridge." And they'll go, "Here you go.
Yep.
And away you go. And of course
Man,
your children will take to it even faster than we do.
of
So
course. Of course. But I mean, this is just so cool. Like, I love it.
yeah.
I absolutely love it.
Yeah, and what it does for me is it just expands what people can be capable of. If you thought, okay, I'm a software guy, even simple things. Here, I'll show you something I've done recently. This is a rack for holding. This is a Raspberry Pi computer, and this metal is called a DIN rail. So I needed to hold this so that I can easily plug in like a power supply and some wires. So I need a prototyping rig, right? And it's like, okay, you could possibly buy that, but I got a 3D printer. So why don't I just print? I looked for a design that had this. I looked for that design, I printed it out, and there's my rig. And now I can start easily doing the tinkering that I'm going to do with my hardware. So for lots of things, you know, all right.
I love that you even have told me about 3D printing, told everyone about 3D printing, the history, the designs, how you could get started, where you could find designs. And I think it's so cool that you came out here to give us all your knowledge. I really
Yeah,
appreciate that.
I mean it's really an accessible technology that why shouldn't we have this, right? It's like it's
Right.
it's not mysterious. It's as unmysterious as a laser printer is. So yeah,
Thank
you're
you so
welcome.
much. Thank you, thank you, thank you, thank you, William. I really
All right.
appreciate it.
Well, this is fun. It's a subject that I really like, so yeah, it was fun.
I can't wait for us to meet again with all the things that you are always up to. I can't wait for us to meet again so you could tell us more about how we can incorporate technology in our lives.
Okay, let's do the next thing.
Alrighty.